Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we are going to discuss about variance concept. Now here in this video, I am going to discuss about properties of variance. And the first property is the variance of the random variable ax is equal to a square times the variance of the x, where small a is the constant, capital X is the random variable. So that is variance of x is equal a square into variance of x, and this is the first property statement. So let us prove that this property. We know that the variance of the random variable is given by variance of x is equal expectation of x minus m whole square. So the mean value of the random variable is denoted as expectation of x or small m. Okay. The definition of the variance of the random variable is variance of x is equal to expectation of x minus e of x whole square. Now here we want to prove that variance of ax. In this definition, x is replaced by ax. We get variance of ax is equal expectation of ax minus expectation of ax. X is substituted by ax. So we know that according to properties of expectation of ax is a expectation of x. Applying this property into here, expectation of ax is a expectation of x. So now here a into expectation of x. So now here both the terms within the bracket term a is the common, a into x minus expectation of x whole square. So a square. So a square is the constant. So using the properties of expectation of a square x is a square into expectation of x. A square into expectation of x. A square into expectation of x minus e of x whole square. So expectation of x minus e of x whole square is variance of x. That is a square. So now here both the terms is a is the common, a into x minus m a square. So expectation of a square x minus m whole square. A square is the constant that is written before expectation. A square into expectation of x minus m whole square. Okay, and what is this one? This is the variance of the random variable. A square into variance of x. Okay, variance of ax is equal to a square into variance of x. So that is the simple proof. Or otherwise, this RHS term we can also prove that first applying the a minus b whole square expansion, a square plus b square minus 2ab, and after that applying the expectation into each term according to the properties of expectation of sum of random variables is equal to sum of their individual expectation. Using that property, RHS term of this equation is a square into expectation of x square plus a square into expectation of m square minus 2a into expectation of mx. So since m is a constant, expectation of m square is m square, expectation of mx is the m expectation of x. So therefore a square expectation of x square plus a square m square minus 2a square m into expectation of x. But expectation of x is also denoted as but expectation of x is also denoted as expected value of the random variable is also denoted as expectation of x or simply m. So m into m square. So this is the m square. So that is a square plus m square minus 2a square m square is the minus a square m square. So therefore variance of x is equal a square expectation of x square minus a square m square. For both the terms, a square is the common. A square into expectation of x square minus m square. So which is equal to a square variance of x, where variance of x is equal to expectation of x square minus m square. So this is very important expression. Keep in mind. Variance of x is equal to expectation of x square minus m square. Okay. So this is the first property proof. The first property can be derived in, there are two cases, there are two methods, there are two ways we can prove the first property. And the second property is the variance of a random variable x plus a is equal to the variance of the random variable capital X. So that is variance of x plus a is equal to variance of x. So next let us prove that variance of x plus a is equal to variance of x. So we know that the definition of the variance of the random variable is given by variance of x is equal to expectation of x minus m whole square. Now here we want to prove that variance of x plus a, okay, variance of x plus a, x is replaced by, x is substituted by x plus a, therefore variance of x plus a is equal expectation of x plus a minus expectation of x plus a. So we know that properties of expectation of uh, expectation of linear sum of random variables is equal to sum of linear expectation. So according to that property, expectation of x plus a is expectation of x plus a. So now here before minus is there, multiplying minus within the bracket term, expectation of x minus, okay, using expectation properties, expectation of x plus a, expectation of x plus a is equal a plus expectation of x. Now here the second term, in this second term applying that property, before minus is there, therefore minus expectation of x minus a. So plus a minus a is the cancel, RHS term is expectation of x minus e of x whole square. So expectation of x minus e of x whole square is the definition of the variance of the random variable. Therefore, variance of x plus a is equal to variance of x. So that is the second property statement and proof. And next third property, variance of x plus or minus y is equal variance of x plus variance of y plus or minus 2 expectation of xy minus expectation of x expectation of y. So we know that the definition of variance of the random variable is variance of x is equal to expectation of x minus m whole square. Okay, here x is replaced by x plus y or x plus or minus y. So the variance of x plus or minus y is equal expectation of x plus or minus y minus expectation of x plus or minus y whole square. So x plus or minus y, expectation of x plus or minus y, suppose this x plus or minus y is the a, this expectation of x plus or minus y is the b, and what is the expression a minus b whole square? First applying expansion of a minus b whole square, a square plus b square minus 2ab. What is the a? X plus or minus y. B is the expectation of x plus or minus y. So therefore after applying variance of, okay, so the variance of the random variable, expected value of the random variable x is also denoted as m suffix x, expected value of the random variable y is also denoted as m suffix y. So now here applying expectation of x plus or minus y, expectation of sum of random variable is equal to sum of their individual expectation, that is expectation of x plus or minus expectation of y. So expectation of x is also denoted as m suffix x. Expectation of y is also denoted as m suffix y. So now applying expansion of a minus b whole square. So expectation of a square x plus or minus y whole square plus b square. And what is the b? Mx plus or minus my is the b. Mx plus or minus my whole square minus 2ab. What is the a? X plus or minus y into b is mx plus or minus my. Now here applying a plus or minus b whole square expansion. Here also applying a plus or minus b whole square expansion. Now we are multiplying a plus or x plus or minus y into mx plus or minus y, multiplying these two terms. Okay, now we are applying. Therefore RHS term, expectation of first term is x plus or minus y whole square, x square plus y square plus or minus 2xy, and the second term is mx plus or minus my. That expansion is mx square plus my square plus or minus 2mx my minus 2. Third term is x plus or minus y into mx mx plus or minus my. Multiplying those two terms, we get four terms. So that are minus 2x mx minus or plus. So before minus is there. Now here in this term before minus is there. So multiplying minus within the bracket term, that plus or minus will be converted to minus or plus. So minus or plus will be converted to plus or minus. So minus into minus plus, minus into plus minus. Okay. At the same time I am applying minus is also within the bracket term. So multiplying these two terms, we get four terms. What are the terms? X into mx plus or minus x into my plus or minus y into mx plus or minus y into my. And after that, multiplying minus within the bracket term, we get minus 2 minus 2x mx minus or plus 2x my minus 2y mx minus 2y my. So next applying the expectation into each term, applying this expectation into each term according to properties of expectation. And what is that property of the expectation? Expectation of sum of random variables is equal to sum of their individual expectation. Using that property, expectation of x square plus expectation of y square plus or minus 2 is the constant, 2 into expectation of xy plus expectation of mx square plus expectation of my square plus or minus 2 into expectation of mx my minus 2 into expectation of x into mx minus or plus 2 into expectation of x my minus 2 into expectation of y mx minus 2 into expectation of y my. Since m is a constant value, expectation of mx square is the mx square, expectation of my square is the my square. So expectation of mx is mx, expectation of my is my. Since mx and my are the constant values. So therefore, expectation of x square plus expectation of y square plus 2 expectation of xy. Okay. Mx square is the constant value, expectation of mx square is mx square, my square is the constant value, expectation of my square is my square plus or minus. Okay, mx my are the constant, expectation of mx my is mx my minus expectation of x is also denoted as m suffix x, expectation of x is also denoted as m suffix x, expectation of y is also denoted as m suffix y, expectation of y is also denoted as m suffix y. Now here plus 2mx my plus or minus 2mx my minus or plus 2mx my is the cancel. So minus 2 mx into mx square, my into my square, minus 2 mx square plus mx square is minus mx square, minus 2 my square plus my square is minus my square. Now here plus mx square, mx into mx square, minus 2 mx square plus mx square minus mx square, my into my square, minus 2 my square plus my square is minus my square. So this term and this term is cancelled. And the remaining term is RHS term is expectation of x square plus expectation of y square plus or minus 2 expectation of xy minus mx square minus my square minus mx my. So mx is also denoted as expectation of x, my is also denoted as expectation of y. So the RHS term of the equation is also written as expectation of x square minus mx square, expectation of y square minus my square plus or minus 2 expectation of xy minus 2 mx is also denoted as expectation of x, my is also denoted as expectation of y. So we know that in the concept of variance, variance of the random variables is also derived as variance of x is equal to expectation of x square minus expectation of x whole square So this one is already derived in the concept of the variance. Variance of x is equal to expectation of x square minus expectation of x whole square. So expectation of x is the mx. Expectation of y is the my. So that is expectation of x square minus mx square. So variance of y is expectation of y square minus my square. So using that concept, so this expectation of x square minus mx square is the variance of x. So this expectation of y square minus my square is the variance of y. So in these two terms, 2 is the common. 2 into expectation of xy minus expectation of x, expectation of y. So this is the third property. Variance of x plus or minus y is equal to variance of x plus variance of y plus or minus 2 into expectation of x minus expectation of xy minus expectation of x, expectation of y. And the expectation of xy minus expectation of x into expectation of y is called as the covariance of the random variable, and it is denoted as covariance of x comma y. So expectation of xy minus expectation of x into expectation of y is called as the covariance of the random variable. So from the above property, so this within the bracket term is covariance of x comma y. So therefore variance of x plus or minus y is equal variance of x plus variance of y plus or minus 2 covariance of x comma y. And the random variable capital X and capital Y are the independent random variable. Expectation of xy is expectation of x into expectation of y. Applying this condition into this equation, RHS term is 0. So x and y are the independent random variable. The value of covariance of x comma y is equal to 0. Covariance of x comma y is equal to 0. Applying that condition into this equation, we get variance of x plus or minus y is equal to variance of x plus variance of y. So this is the another property, and this is another property of the variance of the random variable. So these are some important properties of the variance of variance of the these are some important properties of variance.